Welcome to the NAWT homework. I'm working here in my basement and looking at the homework, O&M homework for number 1. So let's go ahead and work through the first example. So I have a septic tank here that is we're working on that's 62 by 90 by 70 inches deep. And my first question is, what is the gallons per inch as I'm working and dealing with that? So the gallons per inch is equal to the length times the width times 7.5 divided by 12, and that'll give me my gallons per inches. So it's 62 divided by 12, that's going to be the length, times 90 divided by 12, and so those are converting it to feet. My conversion factor then to gallons is cubic feet, and I divide it by 12 as I'm working and dealing with that. So I have those numbers. So now I can go ahead and put that into my calculator. 62 divided by 12 is 5.2. 90 divided by 12 is 7.5. So now I can put 5.2 times 7.5 times 7.5 divided by 12 equals 24.4 gallons per inch. The volume of the tank then is equal to the gallons per inch times the operating depth. So in this example, that's 24.4 gallons per inch times 70. So 24.4 times 70 equals 1,708 gallons. So that would be a 1,700 gallon tank. If the design flow is 300, what's the detention time? The detention time is equal to the volume divided by the flow. So that would be 1,708 divided by 300. So 1,708 divided by 300 is 5.7 days, which is a plenty big tank. If the flow was 400, that would change it to the volume divided by the flow, which would equal the 1,708 divided by 400, which equals 4.3. Again, for a typical septic tank, you want that value to be somewhere between, more than 2 or 3. And so both of those would be plenty big. The next question is, if the scum is 6 inches deep and the sludge is 16 inches deep, should this tank be pumped? Well, the tank is full if the sludge plus the scum is greater than 25%. And so I'm going to go ahead then and calculate that, which is going to be the scum plus the sludge divided by the operating depth times 100. So that is going to equal 6 plus 16 divided by 70 times 100. So punching that in my calculator, 6 plus 16. The brackets means I need to hit my equal sign. divided by 70 times 100 equals 31%. And so the answer is yes, that system would need pumping. Even if it was a year ago, yes, that the use is causing it to need to be full. If the tank had been at 12% last year and is at 23% this year, what recommendation would you make for the system? I would seriously think about pumping, since it looks like it's adding about 11%, and 23% plus 11% is 34%, which is over full. And so I would think about pumping this year. All right, thank you. That's the first example.